this is your section covering matrices. So basically, in short, a matrix is just a rectangular display of numbers. We're going to use them to rewrite systems of equations in this format here. So notice the x and the y are on the same side, followed by the constant on the other side, to what's called an augmented matrix, which some books like to insert a vertical line right here to separate those constants from the coefficients of your variables. Completely up to you on whether or not you'd like that vertical line there. So first thing we're going to look at is giving the dimensions, which is sometimes called the order of a matrix. And what's important about the dimensions or order, which again, whichever you prefer to call it, is they are given based on the number of rows by the number of columns. So row by column. Rows run side to side, left and right. Columns run up and down like columns on a building. So if I look at matrix A here, it has 2 rows. Here's row 1. Here's row 2. It has 2 columns. Column 1, column 2. So the dimensions or order is 2 by 2. Matrix for B has 1, 2, 3, 4 rows, because rows run side to side, by everything is in 1 column, so 1 column, 4 by 1. Matrix 3 has 2 rows by 1, 2, 3 columns. I think there was a 4th. Yep. Matrix D has 1 row by 4 columns. All right. Example 2, write the augmented matrix for the system given. So that's where we're doing this system over to augmented matrix. Make sure your equations are in the correct format before you write it, or you'll have signs wrong. Yeah, the equation should be x followed by y, the equal sign, and then the constant. So if I look at my 2 equations, they are in the correct format. So column 1 of the augmented matrix is the coefficients of x. Column 2 is the coefficients of y. Make sure you get that negative with the 2. Vertical line for separation if you choose. The constants in the last column. Matrix 2. So if I look at these, that first equation is in the wrong format. That 6 is on the wrong side. So I need to move my 6 over. Second equation is good, so I'm just going to copy it. All right, augmented matrix is column 1 is the x column. Column 2 is the y column. If there is a third variable z, column 3 would be the z column. It's not in this one either, so we can just do our vertical line. But it is possible that you will have an additional variable z, and you would just go alphabetical x, then y, then the z column, and then you would do the constants last. Next thing we're going to go over is row operations. So here are the things you are allowed to do with rows. So those are the only operations you are allowed to do on matrices. Swap them, multiply a row by a non-zero number, or multiply a row by a non-zero number and then add it to another row. The point of these row operations is we're going to take our augmented matrix down to this matrix here. This is called echelon form of a matrix, or row echelon form. Notice we have a 1 in the top left, followed by a 0 below it, and then a 1 in the bottom right there. So before we go into fully performing or converting our augmented matrix over to row echelon form, let's go over certain operations given. So first thing we're going to do is change our system of equations over to matrix form. Make sure it's in the right order. So I've got my x's, followed by my y's. I like the vertical line in there, but you don't have to use it, followed by my constants. There's my augmented matrix. All right, so then we're asked to perform this row operation here. So what this 1/3 R1 arrow R1 means, we're going to multiply row 1 by 1/3. And we're keeping it in row 1. So we're multiplying row 1 by 1/3, and that is going to, this arrow means to replace, so we're going to replace row 1 with those new values. So notice it didn't say anything about row 2, so I'm going to go ahead and copy my row 2 exactly as is. We are not changing row 2 at all, only row 1. So I'm going to go one at a time. 3 times 1/3 is 1. -2 times 1/3, -2/3. And 5 times 1/3, 5/3. All right, next thing we're being asked to do is we're going to take this matrix here and now we're going to apply another row operation to it. So this second row operation, what we're being asked to do is multiply row 1 by -6, and we are adding that to row 2. And then we are replacing it with row 2. So we're borrowing row 1 to fix row 2. So notice it doesn't say anything about replacing row 1. So I'm going to go ahead and transfer my row 1 numbers over. 1, -2, and 1, -2/3, and 5/3. I want to go ahead and get those over because we're not replacing them. All right, a little more algebra involved with this step, so I'm going to do some side work. All right, I need -6 times row 1, so 1 times -6, -6. -2/3 times -6, negative times negative, positive, 12/3, 4. And then -6 times 5, -30, divided by 3, -10. And we are being asked to add those with row 2, and row 2 was 6, 2, 1. So column addition, 0, 6, -9. This is our new row 2, so 0, 6, -9. Then we're asked to perform a third row operation. Let's scooch this down so it's actually on it. All right, next one. Here, we are being asked to multiply row 2 by 1/6. And then we are replacing row 2. So we're not touching row 1, so I'm going to carry those over. 1, -2/3, and 5/3. Separation. All right, so we're only adjusting row 2, and we're multiplying by 1/6. So 0 times 1/6 is 0. 6 times 1/6 is 1. -9 times 1/6 is -9/6, which is -3/2. I think that's the last one we were asked for. Yes. So I gave you these row operations in the notes, but what I want you to notice is that this matrix that we ended with here in the far right is the row echelon form of a matrix. I've got the 1 in the top left, I've got the 0 below it, and then the 1 next to that 0. So the reason we want to do this is because this then allows us to easily back solve to figure out what the values of x and y are. So I gave you those row operations initially. Now we're going to go and actually fully finish the problem to figure out the solutions to the matrix, or the solutions for the variables x and y. All right, so in order to get a matrix from augmented to row echelon form, these are the steps you want to use, and they need to be done in this order, or you might have to do extra steps. We don't want to do extra work. So it says multiply row 1 by the reciprocal of A, which is A is what's in that first spot. Notice the first row operation we did back up here. 1/3 is the reciprocal of A. So that's what we did for the first step. The second step is to multiply row 1 by the opposite of what is in that D position, and then add it to row 2. So if you look at our second step, we chose to multiply row 1 by -6, which is the opposite of what is sitting in that D position. And then the last one, I'm running out of highlighter colors, let's go purple. Multiply row 2 by the reciprocal of the second row, second column entry. So if you look at our last one, we chose to multiply by 1/6, which is the reciprocal of the number that is now sitting in that second row, second column entry. If you follow these steps, your matrix will be in row echelon form. All right. So now we're going the full solve. So what we did before, we didn't quite solve, so we're going to do exactly what we just did, but go the extra step of solving for x and y. All right, first things first, you need an augmented matrix. Equations are good, so we've got 4, 7, 5, 8. I like my bar. 10, 19. Matrix. All right, row operations. You need to list your row operations so I can follow them. So first thing is to turn that 4 into 1. So we are going to multiply row 1 by its reciprocal, 1/4, and then replace row 1. So my new matrix, row 2, untouched, 7, 8, 19. Only changing row 1. All right, 1/4 times 4 is 1. 1/4 times 5 is 5/4. Row 10 times 1/4, 5/2. All right, we got our 1. Second row operation is to multiply row 1 by the opposite of what is right below it. So a 7 is right below it. So we're going to multiply row 1 by -7. And we're going to add it to row 2, and it is replacing row 2. This step is to get us our 0. All right, so my new matrix, oops, wrong color. We're not messing with row 1, so I'm going to copy 1, 5/4, 5/2. 1, 5/4, 5/2. All right, we are borrowing row 1, so I'm going to do some side work here because it's a little bit of algebra. -7 times row 1. So 1 times -7 is -7. 5/4 times -7. Watch your math here. -35/4. And 5/2 times -7, -35/2. I'm going to go get row 2. 7, 8, 19. So again, just very, very careful with your basic math here. We're doing column addition. So we've got our let's see what's going on. -7 plus 7, lost my place for a second, 0. For your others, just again, watch your basic math. You don't want an algebra mistake in these because it's going to mess up the rest of the problem. So we're taking our -35/4 and we are adding 8. -3/4. We are taking 19 and adding our -35/2. And we are getting 3/2. And this is our new row 2. So these numbers are now going below here. So 0, -3/4, and +3/2. All right, I ran out of room here, so I'm going to just copy this directly down here just to keep it organized. I'm just going to put it right there. All right, one more row operation left. So third row operation is to multiply row 2 by the reciprocal of what we are trying to turn into a 1. So that's going to be the number sitting next to the 0. The reciprocal of -3/4, flip it, -4/3. So we're multiplying row 2 by -4/3, and that is going to replace our row 2. So row 1 is untouched. 1, 5/4, 5/2. Row 2 is now 0 is 0. Negative times negative, positive. It's going to be 1. And then negative times positive, negative. It's going to be, we've got -12/6, -2. All right, so our matrix is in row echelon form. So then what we want to do is, this is the extra step when you are asked to solve. Now we're going to use what's called back work or back substitution to solve for x and y. So when you do this, start on the bottom row. So we're going to start down here. And what we're going to do is we're going to change from matrix form back to equation form. So on the bottom row, it is 0x plus 1y. So remember, this is the coefficient of x. This is the coefficient of y. That line I like there because it reminds you where the equal sign goes. So if we have 0x plus 1y, that is just y. So we're going to wind up with the bottom row going back to an equation. Y equals -2. I know the value of y. Done. Then you move up a row. So now I'm going to move up to the top row, and I'm going to do the same thing. I'm going to change it back to the equation form. So that top row is, remember, it is going to be 1x plus 5 over 4y equals 5 over 2. So 1x is just x plus 5 force y. But remember, we just found y. Y is -2, so I'm going to go ahead and plug that in here. So let me actually do that in purple, so it kind of matches. And then equals 5 over 2. So now we can do our algebra to solve for x. So x, 5 over 4 times -2, negative 10 over 4, which is going to be 5 over 2. Then we algebra, add to get back to the other side. So we have 5 plus 5 is 10. 10 divided by 2 is 5. So x is 5 and y is -2. Normally we like to write that solution as an ordered pair, x comma y. So these are pretty involved, so make sure your work is kept nice and neat so that I can follow it and see your steps. Next, doing the same thing, solve using the Gauss-Jordan elimination. That means augmented matrix, 2-row echelon matrix, back solve to get x and y. All right, super important here to catch. Your top equation is good, but your bottom equation is not in the right format. So you got to get it fixed first. So 2x plus y equals 1. So here we're swapping the 2y and the 2. They're on the wrong side. So we're going to add 2 to both sides. And we're going to add the 2y to both sides. So we're going to get 4x plus 2y equals 2. Now I can go to my matrix. All right, so first column is x, 2, 4. Second column is y, 1, 2. I like my bar. Third column, 1, 2. All right. First step, get your 1. So that's going to be reciprocal of 2 is 1/2 times row 1. Replace row 1. Don't touch row 2. So our 4, 2, 2 are staying. All right, 1/2 times 2 is 1. And then 1 times 1/2 is 1/2. And then another 1/2. All right, step 2. Step 2 is the more involved step. I need to multiply row 1 by the opposite of what is right below it. So opposite of 4 is -4. And we're going to add it to row 2. And this is to replace row 2 because we need a 0. So row 1 stays the same. 1, 1/2 and 1/2. All right, so I'm going to go do a little side work since it's more complicated. All right, -4 times row 1 is going to be -4. 1/2 times -4, -2. And then another -2. We get 4, 2, 2. And column addition. And then we go 0, 0, and 0. So, now what? Let me get it written in first. All right, so there's 2 things that can happen, or it's technically 3. So the one that just happened where we go on to our third operation and get our final answer, x comma y. And that is when there is a number here besides 0. And then, done. Otherwise, this case. So the other 2 cases occur when these 2 both wind up zeroing out. So when these 2 zero out, it's one of 2 things. It's either infinite solutions or it is no solution. And the key is going to be based on what comes next. If there is any other number here besides 0, there is no solution. So if this would have been 5, 0 does not equal 5. This is false. There's no solution. So you would just simply write no solution and be done. However, when it is all zeros, so if you ever have a row that completely zeroes out, it is infinitely many solutions. Okay. When there are infinite solutions, you have to give me the formula for finding those solutions. And usually they're done by letting either y equal y or x equals x. It technically doesn't matter. So just read to make sure you know whether to put it in terms of y or in terms of x. So I'm going to go in terms of, let's see, we'll let y be y. Okay. So bottom row, here's your work. We're going to start with y is just y itself. So we're going to go to our top row, which is 1x plus 1/2 y equals 1/2. And then what we want to do with this top row is, because y is going to be y, we're going to solve that second equation on the right. We're going to solve it for x. So that means everything's going to be in terms of y. So we would move our 1/2 y over. So we get x equals, it doesn't matter what order you write it in, 1/2 minus 1/2 y. So then we write it as an ordered pair, x comma y. Difference is x is not like a 2 like it was last time. It is 1/2 minus 1/2 y comma y. So this is one way to write it, is in terms of our variable here. The other way to write it is to let x be x. So this is option 1. Let's see, we're going to do a little separation here, and I'll go ahead and show you option 2 just in case. So this was 1, letting y equal y, and that's our work. Option 2 is to let x equal x. So here's option 2. You're going to let x equal x, and it's still, you're referencing that top equation, so we're still going to pull the exact same equation, x plus 1/2 y equals 1/2. But this time we're going to solve for y. So I'm going to move my x over. So we're going to get 1/2 y equals negative x plus 1/2, or 1/2 minus x, either or. And then I'm either going to divide by 1/2. I like to multiply by the reciprocal. 2 is a lot prettier than dividing. So we're going to get y equals negative, distribute your 2, x plus 1. And then this time the ordered pair would be written, we're letting x be x, so x comma negative 2x plus 1. Technically both are correct, so just make sure you're careful whether it needs to be in terms of x or in terms of y if there are infinite solutions. All right, the rest of these are you try it, so feel free to try them and check them with the completed notes. Congratulations, you just finished watching your last video for matrices.